Hi, my name's Gabe. For this problem, we're given two planes, and we're asked to determine if they're parallel, perpendicular, or neither, and if they're neither, we're asked to find the angle of the intersection of the two planes. So let's go ahead and let's review what it means for the two planes to be either parallel or perpendicular. So two planes are parallel if we take a vector which is normal to the first plane, let's call it n1, is a scalar multiple, so is equal to s times a normal vector, or a vector which is normal to the second plane. Let's call that one n2. So this is what it would mean for the two planes to be parallel. For two planes to be perpendicular, well, what we would need is we would need our n1, so the vector which is normal to our first plane, dotted with n2, the vector which is normal to our second plane, to be equal to 0. Now, if our two planes are neither parallel nor perpendicular, the angle of their intersection is going to be given by cosine of theta is equal to the absolute value of n1 dotted with n2 divided by the magnitude of n1 times the magnitude of n2. So now let's go ahead and let's look at our two planes, and from here we can go ahead and find n1 and n2. So let's just start by looking at our first plane, 5x minus 3y plus z equals 4. I'm going to start by rewriting this in the general form. You don't really have to, but that's where I'm going to start. And to do that, I'll subtract 4 from both sides of the equation, which leaves me with 5x minus 3y plus z minus 4 equals 0. So from here, since our equation's in the general form, we can pick up our direction numbers, which tell us that a is equal to 5, b is equal to -3, and c is equal to 1. So a vector which is normal to our first plane is going to be n1 is the vector 5, -3, 1. Now we'll go through a similar process for our second plane. So I can subtract 1 from both sides of our equation of the plane to get the general form. So that's going to be x plus 4y plus 7z minus 1 equals 0. Our direction numbers for this plane are going to be given by a equals 1, b equals 4, and c equals 7. So the vector which is going to be normal to our second plane, n2, is equal to 1, 4, 7. So now we have our n1 and we have our n2. So we can come over here and start working through our tests. So we can just observe that n1 is not a scalar multiple of n2, and n2 is not a scalar multiple of n1. So what that tells us is that our two planes are not parallel. So now we'll want to test if our two planes are perpendicular. So let's go ahead and let's find n1 dotted with n2. So this is going to be our vector 5, -3, 1. And the dot product with our n2, which is 1, 4, 7. So this dot product is going to be 5 times 1, which is 5, plus -3 times 4, which is going to be -12, plus 1 times 7, so plus 7. And here we see that this is equal to 0. So what this tells us is that our two planes are perpendicular. And because our two planes are perpendicular, we know that they're going to meet at a right angle, so we don't need to calculate the angle of the intersection. Thank you.